So in this laboratory investigation, we've seen a pivot video that shows a ballistic pendulum. It fires a projectile out this tube. This is like a PVC pipe with a bunch of holes in it, drilled in it. And a projectile comes out at high speed, sufficiently high that we can't see it. It hits the pendulum, and the pendulum swings upward like so. And we are tasked with simply determining, with a simple question, which is, what is the maximum angle of displacement? So our first challenge in this is using our tools to set the protractor. We need to be very careful in watching the pendulum as it swings to find the axis of rotation. And so we want to spend some time running the video a couple times, placing the protractor so that its center is truly in the axis of rotation. If we put it down further, we would get much higher results, and if we put it up higher, we'd have lower results, and if we put it to the left, we would have, again, skewed results. We want to be careful about that positioning. And we should check, once it's in position, that before the pendulum is impacted by the projectile, that the pendulum is completely vertical. It should read 0. And so that's another check that we have. While we have it set in that position, we should also measure the length of the pendulum. And we can see in trial 1 that there is an X marks the spot in the center of that pendulum, so we might measure from the center of this to the center of the axle to get those measurements. So a very simple question, what is the maximum angle of displacement? But what we notice is as the pendulum goes upward, it slows down and appears to almost come to a stop. And so it spends a fair amount of time at its extreme point. And so it becomes, although it's a very simple question, it's not necessarily easy to come up with a value. So we could just look for it and stop it, advance frames, stopping it where we think it reaches a maximum and take that value. We could do that. But we know the motion is more complex, and to get a more reasonable value, we should study what's going on around it, perhaps during the entire period of motion. So in my particular data table, I set up the trial 1, or case 1 as it's more properly called. Here is my length with the uncertainty, and I converted it to meters. And then I set time 0. I reset the clock to 0 at frame 21, and that was 0.7000 seconds. So now I could actually start at the first moment that I see motion. So I have my frame numbers, which I compute, my times, which I can also compute. I can calculate these and fill down instead of typing these numbers. And then we measure the angular position, which is plus or minus 0.5, and that is the reading error. So that uncertainty is the reading error in this case. And the same thing for the time. Now, if we were to use just this table, so we could, in the video, just advance it to when we think it's the farthest and get a value, obtain a value. We can now also look down the table and look for the greatest angular position. And as we scroll down the list, we seem to get a maximum at 35.1. So that looks to be our maximum value at a time of 0.4333 seconds. So that is the maximum value recorded. And so we have to be careful that the maximum value recorded is likely not to be the maximum value. And that is because for this to be for 35.1 to be the true maximum value, it would require that frame of the camera happen to exactly perfectly catch it at its highest point, which is something we should never expect to occur. So how we check for that, how we can check for that, is to inspect the values on either side of it. And we notice that those two values on either side of it are exactly the same, suggesting that there is this symmetry. It appears to in the frame before, it increases by 0.1 degrees and then it decreases by 0.1 degrees. So it may actually be the case that the frame caught it at its highest location. Let's go one further and we'll see 34.1 and 34.3. Now again, there is uncertainty from our estimating these values, but now it looks like there is not this symmetry. From that point, and if we go to the next pair of points, it's a little bit closer. So there's a question about symmetry here. We think 35.1 is a reasonable value. We should always expect that the highest value recorded in something like this is not the true maximum value. It's just giving us an estimate of where it occurs. But notice now, we're not relying on simply the highest value. We're looking at the values around it to indicate to give us a clue as to whether it is, or more importantly, where the real maximum value is. Is it on this side and higher than 35.1? Or is it on this side and lower than, and also higher than 35.1? So we should always consider the maximum value recorded to be an underestimate of the max value. So then the question becomes is how much of an underestimate? So we can look at this tabularly, and we see it's 35.1 plus or minus 0.5, but we know it's likely to be larger than that.